Section 9.7, the tangent ratio. Section 9.7 and 9.8 are going to be talking about trigonometric ratios. So yes, you did hear that right. This is trigonometry. The reason we're introducing it in 7th grade, we're not doing obviously a whole course in it, but this is like when you learn symmetry. Like you learn symmetry, you start it in like 1st or 2nd grade. Well, you do it 1st grade, 2nd grade, 3rd grade, 4th grade, 5th grade, 6th grade, and we're even going to do it again this year in chapter 13 next in 7th grade. So you start it when you're, younger, and then you just keep adding to it. Obviously, the things we do this year are going to be a lot more complicated than what you first learned when you first were introduced to what symmetry means. Same concept goes here. This year we're going to introduce the trigonometric functions, so trig stuff. The next year and all the years after, you're going to keep adding on to it until eventually you'll take like a whole course in it, and it's going to have a big part of what you learned. So that's the reason we're introducing it this year, and we'll be learning just kind of what those extra buttons are on your calculator. So it's pretty good. It's pretty neat too. You can do a lot of fun stuff with it. Before we get into what it is, I want to go to the next page and kind of take a look with you at example 3, because this is what we're working towards. So after we finish, I'm going to explain example 3, and then we'll go back through, we'll learn how to use tangent, I'll explain what they are, and by the time we get through all of that, you'll see how we can apply it. But it's kind of nice to see how it all comes together, because if we do it the other way, it just seems like random stuff that no one would ever see a need to know about. So here's the situation. It says when the sun's rays strike the moon's surface at an angle of 6 degrees, the edge of a lunar crater casts a shadow that has a length of about 4,700 meters. What is the depth d in meters of the crater the nearest 10 meters? That sounds like a lot, but again, like we've been doing all year, break it apart. It says when the sun's rays, here's the sun, strike the moon's surface at an angle of 6 degrees. So the sun's rays are coming like this. Straight line. But they're striking this moon's surface, this angle right in here, not 60 degrees, is 6 degrees. 6 degrees. So when the sun's rays strike the moon's surface at an angle of 6 degrees, taken care of. The edge of a lunar crater casts a shadow that has a length of about 4,700 meters. This edge here is casting a shadow, so this is like the long shadow. It's 4,700 meters long. So we've taken care of all that. What is the depth d in meters of the crater to the nearest 10 meters? So they want us to find this distance here. Now this is a right angle. So really what we will be working with in this lesson is that we have a right triangle. We have 4,700 meters. We have the side length along the bottom. We know that this is 6 degrees. We don't know either this side or this side, but we are trying to find this distance here. So when we're working with a right triangle, your brain's going to go to a couple of things, hopefully. You first might think, oh, right triangle, automatically Pythagorean theorem. But that's not going to work because we only know one side, we need to know two sides, so that's out of luck. Then you might think, oh, special right triangles, 45, 45, 90, 30, 60, 90. But this is a 6 degrees, 90 degrees, which we could figure that out because of 180. It's going to be 90, 74. Right? So then what we do, we see that that doesn't work either. So this is where the trig stuff is going to come into play. We're going to figure out how to solve for that missing length d. And then you might say, well, why in the world would they need to know this? Sorry, it'd be 84 right here. 84. You might say, well, why do they need to know how long that distance is d? It's on the moon, what difference does it make? Well, let's say that they have this lunar machine that has these wheels. Okay, it's a big thing, it has like a telescope, and they use this telescope to look around the surface of the moon. So these wheels, if it's like a little dip, then maybe it can like wheel right over it and keep going. But if it's like a big cliff, then we want to make sure that we don't go that way. We have this lunar machine go a different way. You might say, well, there's a camera there. True, but maybe we want to, hopefully we have this map planned out, the course of events for this machine before we spend all the money and send it up to the moon and find out we can't go anywhere. So that camera is just out for guidance, but we have to do some math before we even build it or send it up to make sure it's even possible. So that's what we're working towards. Now let's go back and learn what all this tangent stuff is. Wrong page. There we go. Okay. There are these three trig functions. They are called sine, S-I-N-E, is sine. That's why there's that E at the end. Now your button only says S-I-N. So we are going to abbreviate it, and anytime we write it S-I-N, but really we're going to call it sine. The second one is cosine. We're going to call it cosine, but when we write it, we can abbreviate it to C-O-S. And the third one is tangent. I'm calling it tangent, but again, when we write it, we abbreviate it to T-A-N. This is the reasoning for why your buttons only say S-I-N, C-O-S, and T-A-N. They're not sin, cos, and tan. They're sine, cosine, and tangent. Now, we're going to get to this SOHCAHTOA more next lesson, but keep in mind SOHCAHTOA and trig stuff connects. So today's focus, though, is only on tangent. We'll focus on tangent, and then in the next one we'll do sine and cosine and figure out what SOHCAHTOA really is. Okay? So tangent ratio. Each of these three trig functions perform an operation. Just like when we do the square root, this square root symbol represents that an operation of some kind is going to be taking place. Square root of 16 means we're thinking what times what equals 16, and the answer is 4. So sine of something, like if you put it in your calculator, you're going to get sine parentheses. It's automatically going to give you a parenthesis because you're going to take the sine of something, or the cosine of something, or the tangent of something. So this is like it's an operation. It does something. Tangent does something. Okay? So what we're going to do is tangent is always going to be supplied with like a capital letter or a number here. So in this case, it's always going to represent an angle, but in our case, it's just given to us by capital letters. So here we're saying the tangent of A, meaning we want from this angle, we're going to perform our operation. Okay? Now before we do that, let's analyze a few things about this triangle. I could call this side A, this side little b, this side letter c. That would follow my Pythagorean theorem. Notice I have capital letters, just like we saw in the other one, to represent my endpoints or my vertices. They're still A, B, and C, but they're capital. So that difference is important between little and capital letters. All right. My A and my B are my legs. My hypotenuse is C. For the most part, that stays consistent, but when we're doing tangent, we don't want to have two things that are called the same thing because we're going to be making a ratio. So this side here, here's my angle that I'm taking it from. I can almost draw like a little guy. Anytime it says like tangent of A, or if it was tangent of B, we'd take it from here. Tangent of A, we're taking it from this perspective. So from this angle, this side is still going to be known as the hypotenuse. The longest side is always known as the hypotenuse. The one straight like across from it, the side that is across from our angle A, is going to be known as the opposite side because it's straight across. It's opposite. So this is my opposite side. And then the side that's right next to where the angle is I'm talking about, this is known as my adjacent side because it's adjacent to it. I know this one's adjacent to it also, but this one is the hypotenuse, so it can't have two names. So the adjacent's right next to it, the opposite's across from it, and the hypotenuse is the longest one. So the tangent is going to be given to us by a ratio. So we started the angle like we said, and the ratio given to us by tangent is known as opposite. So whatever the length of the opposite side is, you're going to write down divided by adjacent. Whatever the length of the adjacent side is, you're going to write down. So opposite over adjacent. Now let's try this below. The thing we want to remember from this, what we just wrote in, is this right here. This is what we want to remember. Tangent of A, whatever angle we're talking about, is given to us, is equal to the opposite over the adjacent. Okay? So example 1 says find the tangent of angle P for triangle PQR. So this is the angle they want us to find, angle P. So in this case, I'm standing up here. So the tangent of P is going to equal the opposite. The opposite is right here. It's side 4. It's 4. Over the adjacent. The adjacent is the side next to it. Now both of these are next to it, but this is my hypotenuse, so it's going to be 4 over 3. And that's it. That's all there is to it. Now let's say they also wanted us to find the tangent of Q. So that's from this angle. We'll use a different color. That's from this angle. So I'm standing here now. The opposite of Q is 3 over the adjacent, which is 5 or 4, but this is hypotenuse, so it's 4. And that's it.